All right, so now we've finally gotten to the point where we're ready to shoot something, and that is handled in FireSpawn itself, which, as I've said, is attached to the fire point of the left and right gun barrel. So it's actually being called twice simultaneously. I want to make a more general comment here about the way I've distributed code in different scripts and attached them to the different objects. Because some people in coding something like this might be saying, why can't you just have all the code in one place? Like, for instance, in turret control. Why can't I have all of this code here and just tell it what object to apply the particular action to, and then just attach it in one place? And the answer is you certainly could do that. The reason that I haven't is just partly general allegiance to object-oriented principles of encapsulation, where you try to make each class just responsible for one basic kind of behavior here, and and also maybe more specifically in this case, so that I can attach the different scripts to the objects that they most directly affect. And there is one good practical reason for that, which is that having set this up this way, I might decide to move these objects around within the overall gun structure, maybe change the hierarchy. And if I had instead put all of those objects just, let's say, at the top level of the hierarchy or at some other point, and then used some kind of complicated way of locating the correct object to apply the effect to, I could easily break that by moving the object around. Whereas here, there's no like parent, 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 parent or something, walking my way up the hierarchy. It only relies on the basic fact that all of these are children of the gun object itself, or actually the gun structure, empty object itself. So, having said that, let's get into FireSpawn so we can actually shoot some shells here. Alright, so here we have public game objects for the fire prefab and the bullet prefab. As the name suggests, these are actually prefabs. They are public so that they are exposed here, and I am actually going to set these in advance. I know what they are, what they're going to be. They're not going to change during runtime. And in this case, it happens that I'm using the bullet and the muzzle fire prefabs that were defined within this Kawaii Tanks project. I happen to like those, and I mentioned in an earlier video that in fact it's the only thing that I'm using in this project from this Kawaii Tanks project, and there is certainly no reason why you couldn't come up with your own prefab, as I did, for example, with the bullets being shot by my player jet. But in this case, I'm using these ones. And so, the only inconvenience here is that I have to remember to set them separately for each of these fire points. There's ways I could get around that. The reason that I made the whole gun structure a prefab, one reason, was so that I could just set it once in the prefab instance for the whole gun structure, or rather for each left and right fire point. And then I could have, if I wanted to have 20 flak towers, I wouldn't have to keep resetting this. That, incidentally, is another reason why you want to limit the amount of things that you're setting in the inspector in advance, because they can change. If you change the prefab, then it breaks all the instances that point to it, and you've got to remember to redo them all. It can be a big hassle. But in this case, only setting it explicitly twice, once for the left and once for the right, I thought was tolerable. So that's going to take care of both the shell that these people call a bullet, but really it's a cannon shell, and also basically this muzzle flash and smoke here. Bullet velocity is, again, 2000. Now, this is some code that I probably should clean up, because I do end up later getting a reference to the turret control script where I've also set bullet velocity. And so probably it would be smarter to simply derive bullet velocity from the turret script rather than having to remember to keep these in sync, because they do have to both be the same, otherwise the proximity fuse logic isn't going to work. But here I've hard-coded them both as 2000. Spawn offset is to make sure that it's to spawn the shells just slightly in front of the firing point. This brings up another point that you may wonder about. This is pretty standard practice here. Why do I define fire points as empty objects that exist just slightly in front of the actual gun barrels, rather than having the shells fired from the actual physical gun barrel itself? Well, people rarely do that in any kind of a 3D game where you're firing a gun of any kind. And the reason is because if you're instantiating a shell or a bullet and it's got a rigid object, and you're doing it from inside, from the midpoint, which is what would happen by default, of another object like a barrel that also has a rigid body, that doesn't work out very well. In fact, you would need to remember to set an offset that was, just in front of the gun barrel. And that, of course, would depend on what the length of your gun barrel is. And if you changed your gun barrel, you'd have to remember to adjust that offset. That's why people just don't do that. They spawn their bullets or shells from a point just in front. You really can't tell the difference visually as long as the fire point is aligned the same way as the gun barrel. And this is important, because if it's not, and actually you see in my case, because of the way I created the cylinder, they're actually aligned at right angles to each other. And I had to sort of discover that by trial and error, because for a while I was shooting shells, and rather than going out towards the plane, they were going straight down and impacting on the ground and exploding down here. And I finally realized it was because I had originally created this cylinder, as cylinders are always created in 3D, up and down like this, and then I turned it sideways and then shaped it and moved it around, and it still remembered that first rotation. So it has what should be the y-axis, that should be the green arrow pointed upward. It's got it pointed forward instead, as you see. Since the fire point was created as a child of the game object, it originally had that same orientation with the y-axis pointed forward. So what I had to do was independently rotate these fire points upward. It's just, if you create something, an empty object, as a child of an existing thing, it's going to inherit all kinds of properties from it, including its orientation. So I just had to be careful about that. So that's why we have separate fire points that are just slightly in front of the guns and ideally pointed in the same direction. So those are the prefabs. Bullet velocity, I'm still offsetting just slightly forward of where the fire point is, just to make totally sure that we don't have clashing colliders, as the shell has its own collider and so does the gun. We don't want the gun setting off its own shell. The target is a public game object, but again, that's only so that it's visible in the inspector. We're going to grab it from the turret script. Here's the reference to the turret script, as we saw in some earlier script, and the estimated target position and the actual target position. This transform, range, we're going to need here. So on start, we just have start, and we've got a fire function. So on start, I'm setting this transform to this transform, and then I'm getting a reference to the turret script the same way that I did for gun control, and which was simply to go to the root and again, this is why, as long as you know that you can go back to the root and then look for components in children, I can use exactly the same code that I used in gun control, even though these are at very different points in the hierarchy. You still climb up the tree to the root, and then you look back down again for the turret control, which happens to be in the turret object. If you find the script, great, then you grab my opponent from the turret script. You can do this on start rather than having to do it at runtime because the opponent isn't going to change in this case. If I was acquiring different opponents, I would have to do it with some other logic or during runtime. So now we have this fire script, which was what was called by the broadcast message from fire control. All right, so if I have remembered to load in the fire prefab, the muzzle, flash, and smoke, then it's going to go ahead and instantiate that, the fire prefab. It's going to do it at this position, this rotation as a game object. And then it's going to set it to be a child of the fire point itself. And I'm not convinced that this is necessary. I've commented this out and it still worked just as well, but because I had some reason for thinking this is necessary in the first place, it seems to work the same either way, so I'm leaving that in. So that gives us our muzzle, flash, and smoke, which is hardly a critical aspect of this game. It's just a little effect. This is the critical part. You need to have bullets. So if the bullet prefab has been set correctly, again, check it just to make sure that you've got a turret script. So you're loading up the target position, which is the current position, and then the all-important estimated target position. The range now is going to be the distance between this transform, in other words, the guns themselves, and the estimated target position, which is where we think the jet is going to fly to by the time the shell that we're shooting right now gets there. So that's our range. And previously I had also calculated the range to the actual current target position, which is the only reason that I defined this as a variable above. But I commented that out because I decided that it wasn't really necessary for the logic of my code, so you can get rid of that. So here we're instantiating the bullet object, and unlike the muzzle flash, this one we need to shoot forward. So here it's the prefab, and we'll add some velocity to it. But for now, we're just going to set it to this position, but we're going to do it forward times the spawn offset, which is quite small. It's only 1.0, I guess 1 meter, and then at the rotation of this object. So at this point, we've created the bullet, but it's just sitting there. We haven't done anything to it. So now, this is a very important part. We're going to get a reference to a script called bulletNavCS, which lives in the bullet object itself. It has a property called lifetime, and that is the time in seconds or fractions of a second before that shell explodes. So this is basically where we're setting our proximity fuse. And how are we setting it? Well, we're taking the range, which is the distance between the gun and where we think the target's going to be, and we're dividing that by the bullet velocity, which is the 2,000 meters per second. And that's going to get us the time before we want the shell to explode, right? And then finally, having set that, we want to actually put this thing in motion. So we're going to get a handle on the rigid body, and this is why the bullet object, whatever kind of bullet object you want to fabricate or borrow or whatever, it needs to have a rigid body associated with it so that you can impart velocity to it. And I'm simply going to set it, the forward velocity, to the bullet velocity. So now we've created the bullet and we've sent it flying off in the forward direction, which is the direction that the guns are actually pointing. So that is FireSpawn. Now we have shells that are heading towards where we think the target's going to be and fused to explode at the precise moment when their trajectory intersects where we believe the target is going to be.